My warm wishes to everyone. Myself G. Chandana and I am graduating from Srinivas Ramanujan Institute of Technology. Today my topic in this presentation is about a Nyquist plot and also the numerical problem on the Nyquist plot from the control systems. Uh, Now let us see what is Nyquist plot. Nyquist plot is a graphical representation of a system's frequency response, and it is primarily used in control systems and also as well as in the signal processing to access the stability of the feedback system by plotting the open loop transfer functions on the real and also in the imaginary parts against each other in the complex plane. So this Nyquist stability criterion determines the stability of the closed loop system from its open loop frequency response. This Nyquist stability criterion, it depends on the principle of argument. Now let us see what is the principle of argument. Principle of argument, it states that if there are p number of poles and z number of zeros are enclosed by a s-plane, so closed path, then the corresponding g of s into h of s plane encircles the origin with p minus z times. So this principle of argument is applied to the total right half of s-plane by selecting a closed path. So here we use the formula n is equals to p minus z. So n is the number of n cycles. For this number of n cycles, if it is clockwise direction, so it is -1. If it is in anti-clockwise for each circle, it is +1. And also p is poles of characteristic equations which are in right half of s plane, and zeros of characteristic equation which are in right half of s plane is z. So next, let us discuss what is the procedure to draw this Nyquist plot. First step is to replace s in the given transfer function with j omega. So in the given transfer function, we have to replace s we have to replace j omega instead of s, and finding the values of magnitude and the phase angle for given transfer functions in terms of omega. So in the second step, we have to find the values of the magnitude angle and the phase angle for the given transfer functions, and that it should be in terms of omega. For after getting the values of magnitude and the phase angles, we have to substitute omega is equals to 0 and also omega is equals to infinity in both the magnitude angle and also in the phase angle of transfer functions. So by these values of magnitude and phase angles, we have to draw the polar plot on a graph. So now draw the mirror image of polar plot with respect to real axis. After drawing the polar plot, we have to draw the mirror image of polar plot with respect to real axis. Next step is we have to combine original polar plot starting point and mirror image of polar plot ending point with the in cycles continuous direction of polar plot. And the next step is we have to apply the principle of argument, that is n is equals to p minus z, and we have to find out the stability of the transfer function. So if n is equals to p minus z, then that system is said to be stable. If it is not equal, that is n not equals to p minus z, so that system is said to be unstable. Now let us discuss a problem on Nyquist plot. So the question is here. So draw the Nyquist plot for g of s into h of s is equals to k by s into s plus 2 into s plus 3. So this is the transfer function, and also assume that system gains stability k is equals to 1. So question is clear that we transfer function is given and also system gains stability, that is k is equals to 1. So for this we have to plot the Nyquist plot. Now let us discuss what is the solution. So given transfer function is k by s into s plus 2 into s plus 3. So it is given that k is equals to 1. So we written as 1 by s into s plus 2 into s plus 3. So if we substitute in the first step, that is s is equals to j omega. So we'll get g of j omega into h of j omega is equals to 1 by j omega into j plus 2 in j omega plus 2 into j omega plus 3. So we are substituting j omega in place of s. So if we next step is finding the angles of magnitude and also the phase. So angle of magnitude is equals to root of 1 square plus 0 square. Here we don't have the imaginary term, so we will consider as 0 square. Here for magnitude of j omega is square root of omega square plus 0 square. So it is the imaginary term. So real term is 0. We are taking it as root of square root of omega square plus 0 square. For magnitude of j omega plus 2, we are writing root of 2 square plus omega square, and for this term we are writing root of 3 square plus omega square. A is equals to 1 by omega root of omega square plus 4 into root of omega square plus 9. So this is the magnitude angle. And next, phase angle. Phase angle is tan inverse of b by a. In this term b is 0 and a is 1. So we are writing tan inverse of 0 by 1. So next, by tan inverse of omega by 0. Omega by 0 is written as, here j, we have only j omega. So imaginary term is omega and the real term is 0. So we are writing tan inverse of omega by 0, and the next is tan inverse of omega by 2 into tan inverse of omega by 3. So here tan inverse of 0 uh, will be 0, and these terms are in denominator, so we are writing negative, and tan inverse of uh, omega by 0, that is infinity. Tan inverse of infinity is 90. It is in the denominator, so we are writing minus 90, and these two terms are in denominator, so we are writing minus tan inverse of omega by 2 minus tan inverse of omega by 3. So these are the phase angle and the magnitude angle. Now substitute. Next step, we have to substitute omega is equals to 0 and also omega is equals to infinity. If we substitute omega is equals to 0, that in this magnitude term, if we substitute omega is equals to 0, we'll get infinity at the angle minus 90. This is uh, this is how, because 1 by 0 is equals to infinity. So magnitude will be infinity, and the angle, if we substitute here, omega is equals to 0, this term will be 0 and this term will be also 0. So we'll get phi is equals to minus 90. So the angle is minus 90. At the same time, we have to substitute omega is equals to infinity. So we'll get a is equals to 0 at angle of minus 270 degrees. Next, starting direction is equals to pole at origin. So it is at pole at origin, so it is clockwise direction. And also ending direction is equals to pi 1 minus pi 2. So first pi we got is minus 90, and the second one is minus 270. So minus of minus 270, that will be 180 degrees. It is positive, so it is clockwise direction. So from these values we have to plot a graph. So rough diagram of Nyquist plot. So first one is a is equals to omega at the angle of minus 90. So here is the minus 90. It starts from infinity and ends at 0. So this will move like this. So next one is at omega is equals to infinity. So this is the infinite and this is the 0. So A is equals to 0 at the angle of minus 270. So it starts from here at the origin it starts and it goes to the minus 270 degrees. This is the rough Nyquist plot. So minus 1 plus j omega line does not touches any n circuit. So n is equals to 0 and also p is equals to open loop transfer function loop at right side of S plane. So if we see the poles, they are 0, comma, minus 2, comma, minus 3. So no pole is existing on the right side. So P is equals to 0. Next, Z is equals to closed loop transfer function uh, at the right side of S plane. Uh, 1 plus g of s into h of s is equals to 1 plus k by s into s plus 2 into s plus 3. So z is equals to s plus 2 into s plus 3 plus k by s plus 2 into s plus 3. So here the poles are minus 2 comma minus 3. If you see the poles on the right side, so there is no poles, so z is equals to 0. If you substitute n is equals to p minus z, these values in the formula, n is equals to p minus z. So that is the principle of argument formula. So if it satisfied, so the system is stable. If it does not satisfy, the system is unstable. Here n is equals to 0, p is equals to 0 and z is equals to 0. So LHS is equals to RHS. So the given function, the given transfer function system is stable. This is all about the Nyquist plot. Thank you for watching this presentation.